Electricity, the modern friend of man. Can you imagine a day without electricity? Oh, it is impossible. The lights, fans, ACs, to charge mobile phone, everywhere in life we need this form of energy. In order to have electricity, we need charges. Is there any body without charge? Remember, each atom of a body has a central part called nucleus, which is positively charged, and the negatively charged electrons are revolving around them. Normally, the amount of positive charge is equal to negative charge, hence the body is electrically neutral. And whenever there is an imbalance in this share, body is said to be charged or electrified. Now let us define the charge. What is charge? Charge is the property of all matter by which a body can produce and experience electric and magnetic effects. And study of charges which are at rest is known as electrostatics, and study of charges in motion is known as electromagnetics. The SI unit of charge is coulomb. In order to have plus 1 coulomb of charge, we have to remove 6.25 into 10 raised to 18 electrons from the substance. Or to have negative 1 coulomb, we have to add 6.25 into 10 raised to 18 electrons. The dimensional formula of charge Q equal to, remember, charge equal to current into time, therefore the dimensional formula of Q is AT. In CGS system, the charge can be expressed in either electrostatic unit or electromagnetic unit. 1 coulomb is equal to 3 into 10 to the power 9 ESU, or 1 coulomb is equal to 10 to the power negative 1 EMU. Now let us think of how can we make a body charged. One example, charging by friction. Take this case, if you have a plastic scale with you, if you rub this plastic scale on your dry hair and the scale can attract the small bits of paper, how it happens? When two bodies are rubbed together, electrons may transfer from body having lower work function to the higher work function. Thus, both the bodies acquire charge. In the previous example of the scale and hair, when you rub the scale on your dry hair, electrons are transferred from the scale to the hair. So, the scale becomes positively charged and the hair becomes negatively charged. Another method of charging is charging by induction. You take the previous case. The charged scale, when placed close to the neutral bits of paper, the paper pieces gets attracted to the scale. How it happens? How is it possible for the neutral body to move towards the charged scale? This happens because when you place a positively charged scale close to the neutral paper, it pulls the negatively charged electrons towards the scale and push the positively charges away from it. As the positive and negative charges are close, the paper pieces gets attracted. Suppose you have a neutral sphere on an insulated stand and a charged sphere on an insulated stand. Both of them are placed close to each other. The positive charge on the charged sphere, it attracts, it pulls the electrons from the neutral sphere and push the positive charges away. So you can see a polarization of charges there on the neutral sphere. By earthing the neutral sphere, Earth, we know it has a large number of free electrons. The free electrons from Earth move towards the neutral sphere and neutralize the positive charges. Thus, the neutral sphere gets charged. This method of charging is known as the charging by induction. Third method of charging is charging by conduction. In this case, you have to place a charged body and neutral body in contact. What happens? Charge flows from body having higher potential to the body having lower potential till they have same potential. So, when a neutral body is placed in contact with the charged body, charge flows from charged body to the neutral body and both of them have charge now. Is it possible to identify whether a body is charged or not? Yes. Gold leaf electroscope is a device used to detect whether a body is charged or not. Gold leaf electroscope has a metal bulb, a metal conductor and gold leaves. If the instrument is not charged, the gold leaves are in collapsed state. If you bring a charged body close to the metal bulb, the charging by induction takes place. Suppose the body is positively charged, then the metal bulb acquire negative charges due to the attraction and the gold leaves now have the positive charges. So what happens? Two gold leaves have positive charges, so it gets diverged. Collapsed gold leaves get diverged. Similarly, if you bring a negatively charged body close to the metal bulb of the gold leaf, what happens? The positive charges due to attraction, they come closer and negative charges, they move away. So the gold leaves now have equal negative charges, so they get diverged. So when the collapsed gold leaves get diverged, we can say the body we brought close to the metal bulb is charged. Is it possible to identify the nature of the charge using gold leaf electroscope? Yes. In order to achieve this, we need a charged gold leaf electroscope. Suppose the charge on the electroscope is positive. So the positive charges will be there all over the instrument. Due to the repulsion between the positive charges, the gold leaves will be in a diverged state. If you bring a positively charged body close to the metal bulb, what happens? Due to the repulsion between them, the positive charge on the gold leaves increases and the divergence increases. If you bring a negatively charged body close to the metal bulb, due to the attraction, the more amount of charges will be there on the metal bulb, so the divergence of the gold leaves decreases. Let us conclude. If you bring a positively charged body close to the metal bulb of a gold leaf electroscope, the divergence increases. If you bring a negatively charged body close to the metal bulb of gold leaf electroscope, the divergence decreases. Now, what are all the properties of charge? One of the very important property is quantization. Remember, in order to charge a body, we have to either add electrons or remove electrons. Partial removal or addition is not possible. Therefore, charge of a body will always be an integral multiple of charge of an electron. That is what the quantization means. All values are not possible, only discrete specific values are possible. So, charge of a body Q equal to plus or minus Ne, where N is whole numbers 1, 2, 3, etc. and E is charge of an electron, which is equal to negative 1.6 into 10 to the power minus 19 coulomb. The property 2, conservation. In physics, conservation means constant. So the charge of an isolated system remains constant. See in the example, 92 uranium 235 gives 90 thorium 234 and 2He4. On the parent side, we have the charge 92 and on the product side, we have charge 90 plus 2, 92 equal. So conservation means charge of an isolated system remains constant. The property 3, the charge of a body is invariant, means it does not vary. That is, the charge of a body does not vary with speed. Whatever may be the speed of the body, charge remains the same. The property 4, charge is a scalar quantity and it is additive. We can simply add the charge. Property 5, What happens if you place two positive charges close to each other? They get repelled. What happens if you have a positive and negative charge close to each other? They attract. Therefore, the like charges, they can repel, and unlike charges can attract.